We will now continue to determine the center of pressure of this triangular lamina. The figure ABC is a triangular lamina immersed vertically in a liquid of homogeneous liquid of density rho with its vertex A on the surface of the liquid EF. The base of this triangular lamina is A and it is at a depth B below the surface EF of the liquid. We are interested in finding out the center of pressure of such a triangular lamina. In order to determine that, I am dividing this lamina into a number of infinitesimally narrow strips parallel to its base. One such strip of thickness dH of length x at a depth h below the surface EF I have shown in the figure. I am repeating, in order to determine the center of pressure of such a triangular lamina, I am dividing this triangular lamina into a number of infinitesimally narrow strips. One such strip of length x, thickness dH at a depth h below the surface EF is what is shown in the figure. Let us first try to find out the area of the strip. The area of the strip. This is a rectangular strip, therefore length into breadth will give you area of the strip. So now we need to find out what is the thrust on the strip. Thrust on the strip. This is H rho G into area X H. This is the thrust on the strip. Having determined the thrust on the strip, we can find out what is the moment of this about the surface EF. The moment of this thrust about EF is thrust into perpendicular distance from the surface. The perpendicular distance is h. Therefore, I write it as h squared rho g x dh. Is that okay to you? Now, by similar triangles. Okay? I am taking this triangle first. The base of this triangle is x. The depth from the surface is h. X by h. The same thing I have to apply for this triangle ABC. Its base is A. The depth is B from the surface EF. Therefore, from this, x can be written as AH upon B. I suppose you understand this. Now what I am going to do here is substitute this value of x in the previous expression. Therefore, moment will become equal to, okay? If I substitute AH upon B here, this will become A H cube rho G dH upon B. I repeat once again, this value of x I am substituting in this expression. Therefore, this expression moment, the same expression I have written, this takes this form. Is that okay to you? Now, we have determined only the moment of this strip above the surface EF. Since we have divided this triangular lamina into a number of steps, we are interested in finding out what is the total or sum of moment of all such steps. Sum of moments due to all the steps. You understand what I am saying? So, to find out the total or sum of moments due to all such steps, I need to add the moment of all such steps, which means I have to integrate this expression from 0 to b. Therefore, I write it as equal to integral 0 to b a h cube rho g dh upon b. I suppose you are able to follow what I have said here, right? Fine. Then, the resultant of the thrust on all the strips about AB, about EF. This is the moment. We want to find out the resultant thrust of all strips. Therefore, I would write it as integral 0 to b. This is h rho g. In the place of x, I will substitute a h upon b to end up with a h square rho g dh upon b. This is the resultant thrust. Same thing. I could have easily integrated this 0 to b h rho g x dh. I have substituted in the place of x a h upon b. Therefore, I have got an expression. Is that clear to you? Therefore, the moment of this resultant thrust about EF, this is equal to h integral 0 to b a h squared rho g dh upon b, where h is the depth of center of pressure below EF. Very important. Now, sir, this is moment of the resultant thrust about EF. This is sum of moments due to all the steps. Both are one are the same. Therefore, we can conveniently equate this. Where shall we write that? Shall I rub this off? This part I will do. Okay? Hence, this previous expression I have to write integral 0 to b a h cube rho g dh upon b is equal to h integral 0 to b a h squared rho g dh upon b. All other things being a constant, this will have only h cube dh. That will have capital H integral 0 to b h squared dh. Therefore, I will write it as integral 0 to b h cube dh is equal to h integral 0 to b h squared dh. Correct? Integrating this will give me h power 4 by 4 between the limits 0 to b is equal to h cube by 3 between the limits 0 to b. This will be b power 4 upon 4 is equal to h b cube upon 3. Is that okay to you? Now I'll rub this off. This will give me h is equal to 3b power 4 upon 4b cube. This will give me 3 by 4b. So as to say, the center of pressure of this triangular lamina lies on the median AD at a depth 3 by 4b from the surface F. Finish. The center of pressure of this triangular lamina lies at a depth 3 by 4b on the median AD from the surface F at a depth 3 by 4b. Is that clear to you? So this is the first application of determination of center of pressure of a triangular lamina. Now, we need to in a similar way proceed to determine the center of pressure of a rectangular lamina. How to do that? We will see. Let us first change this as rectangular lamina and draw a diagram for that. Okay.